Hello, Matthews, Gatos here. In this chapter, chapter 2 and 9, we're going to be covering radicals and rational equations. So for this lesson, I'm going to do 2.3 and 9.3 together because we're solving them graphically. So let's get started with radical equations. So to review what a radical is, we've got a couple parts of a radical. So we'll look at, first of all, the index. That's that little number there outside of the root. That tells you the root that you are taking. So for this one here, we are taking the third root. Now, if there is not a root showing, if there's an invisible 2 there, and that really just means square root. So here we have the radical symbol that tells me that I'm dealing with a root. And what's underneath the radical symbol, the 15 there, is called the radicand. Now you put all of those things together and you get a radical. So the radical is the whole cool thing. Get it? Radical, cool. Okay, let's look at radical equations. So equations that have a variable in the radicand are called radical equations. So I want to know which of the following here are called radical equations. So let's just go through one at a time. So this first one here, this one is not a radical because only the 2 is underneath the root sign. The second one here, this one is a radical because underneath the radicand, or underneath the radicand contains my variable. This one here, there is no root, so this one is not a radical equation. This one here, there is a radical, and under the radical is a variable. So that is a radical equation. This one here, also a radical equation. I'm taking the cube root. Now, this next one here, it looks like it's just an exponent, but we need to know a little something about exponents. This is like saying 5 times x to the 1/4 is the 4th root of x. So that one there is also a radical, just a radical kind of in disguise. All right, let's look at how do we solve radical equations. Well, actually equations in general. So there's 2 different ways of solving equations graphically. The first one, method 1, is called the intersection method. In this method, we're going to enter in the left side into y1, the right side in y2 as the equation is, and find the point or points of intersection. The solution will then be the x coordinate. Now, I like to use this method to solve word problems and also to check my solution to any type of an equation. I always use method 1. So let's do an example. So we have the root of x plus 5 is equal to 3. So I'm going to put this left side here into y1. I'm going to put the right side into y2, find where they intersect. So that's exactly what I do. Now I want to mention if you're solving something graphically, we want to include a labeled sketch. And by that I mean I want to see my x and y intercepts. I want to see any points of intersection, everything clearly labeled. So now that I've done that, I can see where the solution is, and that is the point of intersection. I'm only looking at the x value for that. So all I have left to do is state my solution, which is x equal to 4, the x coordinate of the point of intersection. Now, if you solve something graphically and you want to check it, you would check it algebraically. So let's look at that. We have the root of x plus 5 equals to 3, and we want to check, does x actually equal 4? So I'm going to replace x with 4. So underneath the radical there, I have 4 plus 5 is 9. And I want to know if that is actually the solution. So the square root of 9 is 3, and since 3 equals 3, x equal to 4 is the solution. Okay, let's look at method number 2, which is the Xintercept method. Now in this method, we want to set the equation equal to 0. The reason I want to set it equal to 0 is because I'm looking at a x-intercept, which is the point at which it crosses the x-axis. And the x-axis has an equation y equals 0. That's why we set it to 0. So once we've set it to 0, we enter left side into y1, right side in y2, and find the point or points of intersection. Again, we state the x coordinate, which is really the x-intercept. Now I like to use this method anytime I solve an equation graphically. So anytime I get an equation and it says solve it graphically, this is what I do. So let's look at this example here. So I want to solve this using method number 2, which means I want to set it to 0. So I'm going to subtract x and 3 from both sides. So just actually make sure that that does equal 0. And then I'm left with 4x squared minus x. I'm going to give myself a little bit more room here. Minus x minus 3 equal to 0. So again, that very first step is to set the equation equal to 0. Now that it's set to 0, I can put this entire side into y1 and put the 0 into y2 and find out where they intersect. And so that's exactly what I do over here. Okay, and in this one here, you can see that there are 2 intersection points. So I have 2 different solutions. Now, these solutions, unlike the other question, are not exact solutions. They are called approximate solutions because I'm rounding these answers. Okay, but those are the 2 solutions. They're approximate, not exact answers. Rational equations. So rational equations are the ratio of 2 polynomials. In other words, it's a fraction where both the numerator and denominator are polynomials. And this is really important. Whatever that denominator is, it cannot equal to 0 because division by 0 is not allowed. Okay, so let's try. I want to determine whether each of the following are rational equations or not. Okay, so looking at the first one, I have a fraction here. 1 is a polynomial. It's a constant. X is also a polynomial. So yes, this is a rational equation. Looking at the second one here, the numerator and denominator are both polynomials, so that is a rational equation. Okay, this next one here, I have x to the negative 2. That really means 1 over x squared. Take the reciprocal of the base and then the exponent is positive. And again, the numerator and the denominator are both polynomials, so that is a rational equation. If I look at this one here, 4 is a polynomial. However, square root of x is not a polynomial. Therefore, that is not a rational equation. So it's not just that it's a fraction, it's that the numerator and denominator have to be polynomials. If I look at this one here, numerator and denominator are both polynomials. They're just in factored form. And then the last one, x is a polynomial, but the numerator is an absolute value. So that is not a polynomial. Okay, so now that we know what a rational equation is, we're going to look at solving it again, just like we did for radicals, method 1, method 2, and then algebraically. So method number 1 again is left side in y1, right side in y2. So it's all set up and good to go. So there is what my equation, when I graph it, looks like. Notice that everything is labeled, including my vertical asymptote. So don't forget to label the vertical asymptote, which of course is the restriction of the denominator. 4x plus 10 can't be 0. That occurs when x is negative 2.5. So that's nicely labeled. So once you've done that, the solution is the x coordinates of the point or points of intersection. So I can say that x is equal to negative 3.3 or 1.1. Okay, let's solve this one using method number 2. So method number 2, the Xintercept method, says I need to set it equal to 0. So I'm going to subtract 1 from both sides. 1 take away 1 is 0. So I would be left with 15 over x minus 1 minus 16 over x plus 2 minus 1 equals to 0. So left side in y1, right side in y2. This will give us a nice clean graph. So you can see there, I have my graph. I can see, looking at the x-intercepts, that I have 2 solutions, x equal to negative 8 and x equal to positive 6. So I can state my solution, but my question really is what's happening in between those vertical asymptotes? When I have my vertical asymptotes found by stating the restriction of the denominator, it separates my picture, my graph, into 3 different sections. If I have 3 different sections, I should expect to see a graph in each section. So I see a graph here, I see a graph here, I don't see a graph here. So what I'm going to need to do is expand my window setting. So when there's 2 vertical asymptotes, I should see graph in all sections. So expanding, making my windows bigger, I can see that there is a whole piece of the graph I wasn't seeing. And so I expanded my window all the way down here to see this graph here. So if this was a question on a test, I would want to see the graph in all 3 sections. It doesn't change the solution, but because we are solving it graphically, we must show a proper graph which is labeled and includes all sections. Okay, to summarize, radical functions, besides being really cool, have variables in the radicand. Remember, you can't square root a negative, so I always want you to pay attention to those restrictions. Rational functions are a ratio of polynomials. Also remember, you can't divide by 0, so you want to pay attention to those restrictions. Now you can solve these functions graphically by using method 1 or method 2, and you can also solve them algebraically using what we learned in 20-1. So this lesson on graphing is really important, and you could say graphing is where I draw the line. Okay, for practice questions, I want you guys to do 1 to 7. Detailed solutions are found on D2L. And then when you're done, you can move on to the textbook questions listed here. So hopefully that helps, and that's our introduction to radicals and rational equations.